All right, today's lesson is 6.3, electric energy and power. So we've already defined what energy is. Energy is the ability to do work, and then work is defined as force, which is capital F, multiplied by distance, represented by the lowercase d, over which the force is applied. So basically the formula for work is force times distance. Force is always measured in newtons. So for example, when a newton of force is applied for 1 meter of distance, it's called 1 Newton meter. And 1 Newton meter is equal to 1 joule of work. All right, so joule is the unit that is used in measuring work. So force is newtons multiplied by distance, which is in meters. So newtons times meter, which gives you Newton meter. And then 1 Newton meter is equal to joule. All right, so the units for work is joule. You can also use newtons times meters as well, but it's normally not used. It is joule that is used for the unit for work, measuring work. All right, so next we're going to talk about power, which is the rate at which energy is transferred. So power tells how fast energy is used or produced. So for example, if a machine uses 1 watt of power, it's using 1 joule of energy in 1 second. All right, so 1 watt is equal to 1 joule per second. Because work and energy are equivalent, power is also the rate at which work is done. So work done quickly means it's got higher power. If work is being done slowly, it means it has lower power. So an example here, electric hairdryer, if it's using 1500 joules of electric energy every second, then it's rated at 1500 watts. A light bulb that uses 60 joules of electric energy every second is rated at 60 watts. All right, so here, this is an example from the textbook using a formula to calculate power. So the formula for power is energy divided by time. All right, so note again that energy is in joules. So we are given here, a generator produces 2 joules of electric energy every second. So we're given our formula, power equals energy divided by time. Energy is 2 joules and our time is 1 second. All right, so first step here is write down what you know. So power is what we're trying to find. Energy is given, it's 2 joules. Time is 1 second. And here's our formula. Power equals energy divided by time. All right, what are we trying to find out? We're trying to find out how much power is produced. So using the formula and substitution, so you're going to put 2 joules for energy, 1 second for time. So it's 2 divided by 1, which gives you 2 joules per second. So expressing that in watts, 2 joules per second is equal to 2 watts of power. What do you buy from the power company? So power companies provide electric energy. So when you're paying the electricity bill, you are paying for electric energy. The consumption of electric energy is measured in watts, and then the watts are multiplied by the time it takes to use them. So if an appliance uses 1 watt of power every hour, it's using 1 watt hour of energy. All right, so the energy is power multiplied by time. So 1 watt hour is 1 watt times 1 hour. All right, so for example here, how much electric energy does a 1 watt light bulb use if it is left on for 2 hours? Okay, so again, step 1, write down what you know. We know the power is 1 watt. We know the time is 2 hours. We're trying to calculate the energy. Okay, so that's step 2. What are we trying to find out? Question number 3, step number 3, use the formula, which is energy is equal to power times time. So it's 1 watt times 2 hours. So it's 2 watt hours of energy. So the light bulb uses 2 watt hours of energy. Now, normally, watt is not used because it's a small unit of energy. It's usually kilowatt hours that are used. So 1,000 times larger than a watt is the kilowatt hours. And that's what we'll be using. So 1 kilowatt hour is equal to 1,000 watt hours. So an appliance that uses 1,000 watts for 1 hour and a small light that uses 1 watt for 1,000 hours, both are using 1 kilowatt hours of energy. All right, and you may have seen something like this, electric meters, which measure electric energy in kilowatt hours. All right, so here we have an example showing how to calculate kilowatt hours. So a small kettle is rated at 1,000 watts. That means it's using 1,000 watts for each hour it is used. So during 1 week, it's used for a total of 2 hours. How much energy does it use in kilowatt hours? All right, so start with step 1. Write down what you know. We know that the power is 1,000 watts. The time is 2 hours. And the energy is going to be power times time. We're trying to find out how much energy is used in kilowatt hours. So using our formula, power times time, it's 1,000 watts multiplied by 2 hours, which gives you 2,000 watt hours. But we need to change this to kilowatt hours, so we have to divide by 1,000. So you're going to take that 2,000 watt hours, divide by 1,000 to put that into 2 kilowatt hours. All right, so going from watt hours to kilowatt hours, you have to divide by 1,000. All right, so our final answer then, how much energy does it use in kilowatt hours? The kettle uses 2 kilowatt hours of energy. All right, so you're going to do some practice calculations now. So there's 2 Math Connects on page 109, numbers 1 and 2. So there's a total of 4 questions on page 109. And then on page 110, there's 2 questions as well. And then at the end of 6.3, there is the summary question. So check your understanding questions, numbers 1 to 3.